as we go along. If you're not too sure why I'm saying something, and I might actually ask you questions as we go along as well, but I do want to sort of balance time versus getting you sort of engaged with what we're doing here. I guess when you look at this first set here, it was, it was kind of a deliberate mixture of problems here. And what you really needed to do is you needed to join each bit of A, B, C, and D with the sentence that made the most sense, I suppose. And what it was really asking you to do was, do you recognize the shape of an expression? Do you recognize what it looks like? And it's the kind of stuff that, you know, that flowchart I gave you yesterday is really looking for. So, for example, is it a difference of two squares? A squared minus b squared turns into a plus b, a minus b. So you look at that first one there, and it's m minus 2, m plus 2. That is a difference of two squares that has been factorized. That's what made it a bit tricky, I suppose, is that you're looking at the factorized expression rather than the initial expression of m squared minus 4. So this is a difference of two squares, like so. M squared plus 4m plus 4 is a perfect square. Things that we look for in the unfactorized expression. We've got three terms. Tick for perfect square. We have a square for one of the terms, it's m squared. We have a square for the second term, it's 2 squared. And if I mush those together, I get 2m. And then if I double it, I get 4m. So it's a perfect square. So that links up to there. Does that make sense? Okay. Now, grouping in pairs is almost always 4 terms. You can't always group in pairs, even if it is 4 terms. But in terms of I've got 4 options and 4 possibilities, the only one for grouping in pairs has to be D, because there's 4 of them. And that leaves that last one. And just to check, is it a quadratic? A quadratic simply means something squared plus something plus a constant number. So m squared plus 5m plus 6 is a quadratic. Normally it's x, but it doesn't have to be. And secondly, monic simply means that there's nothing before the squared term except for 1, which may or may not be there, usually isn't. So there can't be a number in front of m squared unless it's 1. So that is a quadratic monic. Now, technically, I should point out that this is also a quadratic monic trinomial. It's a square and it's monic and it's a trinomial, tri meaning 3, 10. So yes, it is also a quadratic monic trinomial, but more than that, it's a perfect square, which is why it links up there and not down there. Okay, that's it for that one. Moving on. Alrighty, so moving on to the next one, we've got expand and collect like terms. Now, the thing I wanted to say about this first one here is it's the one where it's a simple problem, and what you need to get to, it's okay if you're not there yet. And it's not like I took any marks off, but what I wanted to see, believe it or not, for a maths teacher is less working out. And not because you're just hiding it from me, but because you can do it in your head, right? That's what I want to see, or kind of, if you know what I mean, because you need to build efficiency in your problem solving so that you can get onto harder problems without it getting in the way. So this is what I'd be doing in my head. In my head, I'd be going, well, I've got my m times m is m squared. So I go equals m squared. And then I'm going, now I've got 1m there and minus 3m there. So I've got minus 3m plus m. So I've got minus 2m for the middle bit. And then I've got 1 times minus 3 is minus 3. So it's m squared minus 2m minus 3, straight up. Now, if you use the box method, that's okay. There's nothing wrong with the box method or the chicken beak method. But again, I'd like to see you sort of developing that sense of, well, I think I can do this in my head, and practice doing it in your head. Similarly with this one here, m minus 5 all squared. It was disappointing to see when students decided to do this by breaking it to m minus 5 times m minus 5 and using the box method. You need to apply the rule directly. Even if you can't go straight to the final answer in one go, apply the rule. When we expand, I'm just going to zoom this up just so I can write a bit smaller. When we expand, first of all, we expand the first term, m squared. Then we mush these together and double them. So that's minus 5m doubled to minus 10m. Minus 10m. And then it's always plus the square of the second one, which is 5. So squaring that to 25. So you may feel like the box method is faster, but it's only faster because you're more practiced at it. I think I've been through this with you a few times, haven't I? This false idea that I should use the one I'm most familiar with. Because what it stops you doing is practicing the thing you're unfamiliar with until you're better with it. Okay? Don't forget, if you've already crossed this stuff, you don't need to follow on with me. You can just get on with that factorization sheet. You don't have to follow on with me if you're already okay with this. You can dip in and dip out as I go along. Okay, the next one here, I think people did fine with if they sort of did fine with the two problems above. And it's one of those things where if you're stuffing up the early problems because you don't know what to do, the other problems are going to be no better. Oh, by the way, I would expect students who are following on with me to actually be writing down corrections as well as they go along. If you just stare at the board, what you'll get is, well, even more bored than you should be. If you write it down, there is some actually good serious science to say the act of writing it down helps reinforce it in your brain. There's something kinetic about writing that allows it to make a connection in your brain. So if you're writing down the solutions as you're working on them, as you're listening to me, you're more likely to develop a better understanding and memory over it. That's what the science says. So the first step, I would do this in a couple of steps. The first step is to expand these two here. So again, I'll do it in my head, but I'll explain my thinking. I'm multiplying the m's together to get m squared. I'm then multiplying, let me see now, I've got 4m here minus 3m here. So I've got plus m. And then I'm multiplying 4 times negative 3 to get negative 12. And then I'm expanding m plus 1 all squared. Now that's a perfect square again. Some people did box method, but you shouldn't. You should go straight to using the rule. And the rule is square the first term, mush these together, so 1m becomes 1m, or just m, and then double it, so it's plus 2m, and then square the second term, which is 1, and 1 squared is 1. Okay, this is where I saw something which I shouldn't see. In fact, I want to make it clear to you, everyone in this class deserves to be here. So this little tiny growl is because I know every student is better than this, right? So I'm not having a go at people who I don't think are capable. Everyone's capable of this. The number of people, I'll draw it in a different color so you know it's wrong. The number of people who when m squared plus m squared is equal to m to the power of 4 was too high. If you did it, you weren't alone. There was a bunch of people here that when m squared plus m squared is equal to m to the power of 4. I'll show you how silly that is. It's like saying 9 plus 9 equals 81. There's no one in this class who would say 9 plus 9 is equal to 81. And yet, there are people here that definitely, it was letters instead of numbers, that did something similar. Because 9 is just 3 squared, and 81 is just 3 to the power of 4. That's not true, is it? Now, a lot of people, I think it's a real, I'm not too sure where it comes in your development of maths, but a lot of people want to treat algebra different from numbers. But in fact, algebra is number. It's just using letters to represent numbers we don't know yet, or numbers that can change based upon the scenario, hence variable. But they act the same way. If you can't say 3 squared plus 3 squared is 3 to the power of 4, you sure as heck can't say m squared plus m squared is equal to m to the power of 4. Okay? This next step is what we call collecting like terms. And that means a term is a like term if it has the same variables in it with the same powers in it. So m squared and m are different terms because m has different powers. But this m squared and this m squared is the same term, or it's a like term, so I can add them together. And when we add them together, we just treat them like I've got one of them, and then I've added another one of them, so I've got two of them. So it's 2m squared. Does that make sense? And you know what? I get that in the heat of the moment, you can make that mistake even though you know it's not true. But fluency is when you can do things without much thought. You need to get to the point where you're not making m squared plus m squared equals m to the power of 4 kinds of mistakes. Because when you do that, it shows me not that you're stupid, because I know every student here is not stupid, but it shows me that you don't have fluency over it, which means it's not like this, automatic. M squared plus m squared, it's 2m squared. I'd never say m to the power of 4 because it doesn't make numerical sense. And that's what you just need to develop. I still have students making those mistakes in grade 11. You know, they need to break the habit. Let's try and break the habit now in year 9, right? You know, when you've still got plenty of development ahead of you. Get to year 11, it gets harder and harder. Next like term is m and 2m. So I've got plus 3m, and minus 12 plus 1 is just minus 11. So it's 2m squared plus 3m minus 11. I'll stop there for questions. I don't care what the question is. There's no such thing as a stupid question. Well, there are. There's rarely a thing like a stupid question. It's just stupid not to ask them. No, okay, moving on. So that's expansion, and we hadn't done expansions in a while as well. And that's another thing that kind of might have got you a bit stuck there, but you need to develop that. Number 3, p squared minus 25. So if you have a look at the chart, is there anything that we can factorize there? It's p squared minus 25. The answer is no. There's nothing we can factorize there. So is it a difference of 2 squares? And you look at it, and it kind of looks like it might be, because there's 2 terms and there's a minus. But we just do a check. And the more you practice it, the more efficient you get at doing this check until it's second nature. Is p a squared? Oops, is p a squared term? Yeah, it's p squared. Is 25 a square term? Yeah, it's 5 squared. So I've got p minus, so you don't have to write this. I'm going to write it just for this first one. So you can write it as p squared minus 5 squared. And now you can apply the pattern. And the pattern, or the rule, is that if it's like this, we go a plus b, a minus b, or the other way around, doesn't matter. So I would get p minus 5, p plus 5. If you wrote p plus 5, p minus 5, it's exactly the same. There's no dramas there at all. Any questions? This next one. Some students use the box method or something similar, or split the middle term. All of that's fine. For something like p squared minus 5p minus 6, as an extended student, work towards doing it in your head rather than boxing it out. Remember that for maths extended students, sometimes less working out shows better understanding at a higher level, but I'm only talking about for straightforward problems. So what I'm doing in my head is I'm going, what 2 numbers multiply together to give me minus 6 that add together to give me minus 5? And literally in your head, you can start listing off the factors. So we've got minus 3 and minus 2. No, so minus 3 and minus 2 would give me positive 6, wouldn't it? So that doesn't work. So one of them has to be positive, one of them has to be negative. Minus 3 times positive 2 will give me negative 6, but minus 3 plus 2 is minus 1, so that doesn't work. Minus 6 times positive 1, oh, that's right, it gives me negative 5. So then I can go p minus 6, p plus 1, and I'm done. So you can do that. As a look, a tiny middle step, if you need to, just list the factors down the side. So I can have what? You can just go, I can have negative 3 times 2, or 3 times negative 2, or 1 times negative 6, or 6 times negative 1. So you can put them all down and then have a look at them and go, oh, it's 6 times negative 1. That if I add those, I'll get it's 1 times negative 6. If I add those together, I'll get negative 5 in the middle. So you can sort of develop that sense. But that's basically what you're doing for monics. You're just saying what 2 numbers multiply that together to give me this, that will add together to give me this. And more than one person did confuse those 2 facts. They looked at what multiplied together to give me -5, that added together to give me -6. So you just got to be careful. This one here was done all right. Most people saw, which I was really pleased to see, most people saw that there was a common factor of 5 first. So you got p squared plus 2p minus 3. So a la this chart here, take out highest common, Hookerfoot first, take out the highest common factor first. Is it a difference of 2 squares? No. Is it a perfect square? No. Is it a monic? Yes. Can we factorize it? Probably, because it's in the test. So we keep the 5 outside off to start with, but now we look at factorising the inside. And we use the same logic as this. Two things that will multiply together to give me -3, that will add together to give me 2. And the answer is 3 and -1, right? So it'll be p plus 3, p -1. And you can always double check, right? So if you do it, double check your work. 3 times -1 is -3. 3p here minus p here is 2p. Yep, I've got it right. So you can always double check your work if you've got time. In a quiz, you don't always have time, but if you've got time, it's probably a good idea. If you didn't see there was a highest common factor of 5 here, you did make your life a lot harder to try and solve this one. P squared minus 16p plus 64. Number 1, is it a highest common factor? No. Number 2, is it a dot? No, why not? Sorry? Well, because it's a perfect square for sure, but straight away it's got 3 terms, right? So it can't be a difference of 2 squares if there are 3 terms, because it's a difference of 2 squares. We do have 2 squares though. This is a square, and this, Sam, is 8 squared. So if I say that's a square and that's a square, that makes me suspicious that this is a perfect square. Let me have a look at mushing it together. So I've got 8 squared here and p squared here. So 8p would be the mush, and I double it and I get 16. Great. That fits the pattern of perfect square. I cannot emphasize enough that what you need to do as a mathematician is you move from explicitly thinking about it. Do I have this? Do I have this? Do I have this? Yes, I do. Therefore, I use it. Trust me, with time, you'll do what Sam did a second ago, is he looked at it and went, oh, it's a perfect square. Right? You will get that eventually. It doesn't matter if you're not there yet, but the building block between looking and seeing it's a perfect square, the building block is test it. Test the expression. Is this a perfect square? Yes. Is this a square? Yes. Is this a square? Yes. What is it? It's 8 squared. Do I have twice 8p in the middle? Yes, I do. There's my third tick. Therefore, it's a perfect square. That's the building block between those two stages. But trust me, it might feel like a lot of brain movement there, but trust me, over time, you'll jump from here to here like Sam did a second ago. I look at it, yep, that's a perfect square. So we've got p minus, because we keep the same sign as this, 8 all squared, and we're done. There's the whole page done. I'm going to move on to the second page now, but I will ask if there are any questions first. Okay, so for those of you that haven't been following on, I'm about to start page 2. So if you've got problems on page 2 or issues with page 2, now's the time to tune in. Look how big that box is. Look how many marks it's worth. So you know that it's not necessarily as straightforward as the other ones. So there's a couple of things going on here. The first bit is somewhat straightforward. We just expand m plus 3 times m minus 1. So we get m squared, and we've got 3m minus m is equal to 2m. And then we've got 3 times minus 1 is minus 3. That's the first bit. Ladies and gentlemen, I do this. I encourage my grade 11s and 12s to do this. I encourage you to do this. When there are negatives involved, especially negatives outside the bracket, take an extra step. Because even for the quick-witted, you can easily make a negative mistake. So take an extra step. So this is one of those cases, even as a maths extended student, I would like to see you doing an extra step. I will go minus, bracket, and then I'll expand m minus 2 all squared. Square the m, m squared. Mush them together. M times 2 is 2m. Double it, 4m. Keep the minus because it's a minus in the original factorized expression. Square 2, it's always plus. Square 2 to get 4. So we've got m squared minus 4m plus 4. Now I'll deal with the negative. What we are doing, ladies and gentlemen, is there's an implied 1 outside here. So we're kind of multiplying each thing by minus 1. That's the logic behind it. But the practice behind it is I simply swap the signs of the things inside the bracket now. So I've now got minus m squared plus 4m minus 4. Can you see how those signs switched? That's now minus, that's now plus, that's now minus. Yeah? Okay, and now we collect like terms. We don't have m to the power of 4, right? The only way of getting m to the power of 4 is if we multiply powers together. We are adding them, and so we collect like terms. M squared minus m squared is 0m squared, so it's gone. 2m plus 4m is equal to 6m. Minus 3 minus 4 is minus 7. If you have a look, if you had a really good go at that problem and you didn't get the right answer, is it because you stuffed up the negative work? Because a few of you did. Questions, comments, thoughts? Next one. Factorize the following. We always have to start with highest common factor. We are going to follow through this flow chart. Hookup, dots, PS, monic, non-monic. Always in that order. So is there a highest common factor for this first one? No, there isn't. As soon as I see, well, can I say that? I think so. As soon as I see an even number and an odd number, I'm not going to get very far necessarily. Oh, that's not true. But there isn't anyway. 4 goes into these two, but doesn't go into this one. Remember, it's a highest common factor, which means it has to be a factor of all of the expression, not just a part of it. So there's nothing that's there for all of it. Now, we were practicing these yesterday, so perhaps I won't go too crazy. But when we look at the terms to see whether so it's not a dots, by the way, because there are 3 terms. Gone. The next thing we do then, is it a perfect square? And the answer is yes, it is. I'll explain why. Looking at that first one, I can see that the number is a square, it's 2 squared, and the letter is a square, it's p squared. Similarly here, it's 3q. Okay, so we've basically got 2p as the first term and minus 3q for the second term. And it's just as a quick check, because just in case the teacher decided to trick me, I'm just going to smush these together. 2 3s are 6, 6pq, and double it. Do I get 12pq? I do. Okay, all of this you can do in your head pretty quickly when the more practice you do. This one here, you might be suspicious that it's a dots, but right now it's not, because I don't have a square minus another square. 12 isn't any particular number square, so we don't have it yet. But if I went straight to dots, I'd be doing the wrong thing anyway, right? Because the very first step always is hookup. Someone else? What's the hookup in this case? What's the highest common factor? 3. Good. A few people saying 3. So if I take 3 outside of it, 3, what's 3 times? 3 times 9 is 27. So I'll get 3 outside of 9p squared minus, and 3 4s are 12. So I've got 9p squared minus 4. Now I've got a dots inside the brackets. Double check. Are there any highest common factors left? No, I've definitely got the highest. I've definitely factorized it properly. So now I will go 3, and 9p squared is 3p. 9 is 3 squared. P is p squared. So I've got 3p minus 2, 3p plus 2. And I'm done there. Yeah, so algebra is a combination of 2 kinds of things you need to get used to, I suppose. Number 1, you have to get rather process-driven. Try this in a particular order, just for efficiency's sake. but there's also about toolbox, like algebra is like a toolbox and you need to pull out the right tool. So you need to be able to look at it and then pull out the right tool. Over time, this thing here is less important because what you'll do is you'll go, well, take this one here for number, oh, you can't see it. Take this one here that we just did, number 5, 4p squared minus 12pq plus 9q squared. What you'll do over time is you'll look at it and go, well, I can't factorize it and I can see it's a perfect square, so I'll do perfect square. Over time, you just do it a lot faster. You don't go, does it have a highest common factor? No. Is it a difference of two squares? No. Is it a perfect square? Yes. You do that initially while you're building up your skills, but once you're there, you go to it really quickly. Trust me on that, please. All right. 10m squared minus m minus 2. Does it have a highest common factor? No, other than 1. Is it a difference of two squares? No, because there are 3 terms straight away. Even if that was 10m squared minus m minus 4. Is it a perfect square? No, because if it was, one of these would be a square as well, and it's not. So that leaves us with, is it a monic trinomial? No, because there's something in front of the m squared. So it's a non-monic. So the method that I have taught you to use, and I'm really pleased to see some of you doing it, but not enough of you, is the diamond method. So I multiply these two things together and I get minus 20. And I've also got a minus 1 and I circle that. So I need two numbers that will multiply together to give me 20, and this tells me apart, that are one number apart. So again, in your head or off to the side or somewhere, you list those factor pairs. So you've got 10 times 2, but that's not one number apart. I'm ignoring the negative at the moment. I'm just looking for two numbers that will multiply together to give me 20. 10 times 2, but that's not one apart. 5 times 4 is one apart. Okay, so I've got 5 and 4. So I've got 5 and 4 are one number apart. And then I put this sign here on the biggest of the two. So that's negative 5. And then I know I need to add 4 in order to get to negative 1. So that's it, negative 5 plus 1. And then I put 10m on the top here. And I put 10m on the top here. And then I cancel down my fraction, just the number part of the fraction. I'll do it in red so it stands out. So 5 goes into itself once and goes into 10 twice. 2 goes into m twice and goes into 5 times. So I'm left with 2m minus 1 and 5m plus 2. And that's it, I'm done. Practice, practice, practice. The diamond method is really methodical. Do this, do this, do this, and then you get the answer at the end without too much thought. Practice the diamond method. This one here, go through the process again until you're familiar with it. Is there a highest common factor? Yes, there is. What is it? 2. So we've got this equals 2 outside of 3m plus mp plus 3 plus 2p. There are 4 terms, which means it's not going to be dots, difference of 2 squares. It's not going to be a perfect square because there are 4 terms. It's not going to be a monic or non-monic because there are 4 terms. In other words, the only thing that fits the pattern of 4 terms is grouping. So that's what we'll do. So that's equal to 2 outside of. I'll just group the first 2 and the last 2, I suppose. Doesn't look like it's going to give me my answer, though. What have I stuffed up? There shouldn't be a 2p there, should there? That's what you get used to as well, the more you do your maths, is that you get used to looking at the line above and going, oh, this doesn't look like it's right. And then it gets you to question it, and then you realise you've stuffed up, and then you can sort of go on. So that's just something to take in mind as well. So I've got a common factor of m here, and that gives me 3 plus p. And then I've got there's no common factor here, so I can just go 3 plus p here as well. And if you like, I can put a 1 outside because it doesn't matter. 1 times anything is just itself. Close the bracket. And that leaves me with 2. And I've got 3 plus p as the common factor here. So there's 3 plus p. And there's m plus 1 as my second one. So Don't get me wrong, I reckon, remember this is a maths extended class as well. So you shouldn't expect this to be as easy as regular grade 9 maths, right? You should expect to get, like, if you're used to getting B's and A's in regular maths, then the fact you're getting C's and B's or even T's is just means that you're tackling stuff that's a lot harder than you're used to. So take heart with that. You've deliberately chosen hard maths to do. So even at maths extended level, I would say the fact that this is you have to take that out, and then you have to think of a factor of 1 here. That at least puts it to B level to my mind. It's not just like, oh, everyone should know it. You need to be pretty good to see that you got to put a bracket there and then there's a 1 there. Everyone can get there, but I'm just saying, don't be too hard on yourself if you don't see it yet. There we go. That's that page done. Any questions? I hope this is useful. As usual, I'm not getting a lot of feedback. We're getting to the harder stuff now. We're getting to the harder stuff. And it's hard because you've got to, technically speaking, juggling 3 balls or juggling 5 balls is not, there's not much of a change of technique, but juggling 5 balls is still juggling, still harder than juggling 3, right? The point being is that what makes these problems harder is that there's more bits to it. The individual bits aren't any harder than anything else in the quiz, but the fact that there is more in it makes it a bit more difficult, I suppose. So let me zoom up on this first one here. And I don't want to do the box method, but I'll just set it up so you can see what it would look like. I don't have enough space really. But if I was doing this via the box method, you basically have to have a box for each term. So because there are 3 terms here, you do need to have your box split into 3 columns and then into 2 rows there. And then you'd go m plus 2, and then you'd go m squared minus 2m plus 7. That's how you would do it. I'm not going to do it like that. I'm going to do it via the chicken beak method. But I'll refrain from drawing the chicken beaks because it does make it a little bit messy to see when you're looking back on it. So I multiply each term by this variable first, and then each term by this variable here. Sometimes it's called the FOIL method. Was it in this class that someone wrote FOIL on their paper? No, it was something. I think it might have been my grade 11s. So here we go. M times m squared is equal to m cubed. M times minus 2m is minus 2m squared. So all I'm doing is I'm upping the power of m by 1. M times 7 is plus 7m. Now watch what I do here, guys. For my second expansion here, what I'm going to do is I'm going to put my second line of expansions along this line underneath, and have a look at how I do it. I think it's a really nice way of doing it. 2 times m squared is 2m squared. So what I'm doing, I'm putting my like terms underneath each other because then I can do a column add. 2 times minus 2m is minus 4m. And 2 times 7 is plus 14. So now I won't put the line there, but I'm basically doing a column add that way. So the like terms are already underneath each other. So it's a really nice way of just setting out your work so you can get your answer without stuffing up. That's what I tend to do with most of my maths, is I tend to put things in place for myself so I stuff up less. I still stuff up, but I stuff up less. So I've got an m cubed here, minus 2m squared plus 2m squared. They're gone. They disappeared. I should have put a plus there. So they're gone. Plus 7m minus 4m is 3m. So I've got plus 3m plus 14. Done. What do you reckon? So if you're not going to use the box method also allows for really well organized like terms. The diagonals make the like terms. That's really handy. So if you're not going to use the box method and you're going to use the expansion method like I've got here, the chicken beak method, then I really strongly recommend that you do your setting out like that. This was just annoying. P plus 2 times P plus 2 cubed. I'll do it, but we'll see how we go. This is the trick. P plus 2 all cubed is P plus 2. Now, some people went, where did that come from? Okay, I'll talk to you after class. P plus 2 all cubed. Some people went P plus 2 times P plus 2 times P plus 2, right? I get why you did that. Personally, I would do this. P plus 2 times P plus 2 all squared. Why? Why wouldn't I just break it into the three factors? Why have I got it one of the factors times the other factor squared? Okay, this is what makes it an A standard question. Because I have a pattern for something squared. It's the perfect square pattern, right? The perfect square rule. So why create extra work for myself? Think smart, work less hard, effectively. Because I can now go P plus 2, and I've got P squared plus smush 2P together, double it to get 4P. So plus 4P plus 4. There you go. I've just expanded two of them. And now the problem is no harder than this problem, which was hard enough by itself. But it's no harder than that. So work smart so that you can, work efficiently, I suppose, so that you can move through it quickly. Now I'll do the same thing again. I'm multiplying everything in this bracket by this term, and then I'll multiply everything in this bracket by this term. So I'll get P cubed plus 4P squared plus 4P, and then I've got 2 times P squared is 2P squared, 2 times 4P is 8P, and 2 times 4 is 8. And then my final line is P cubed plus 6P squared plus 12P. So easy to do this last line when they're all in a column addition. Plus 8, and I'm done. Okay? You will develop these skills as you go along, where you can see these little shortcuts as you go along. 4 more problems, and I've got 5 minutes. Let's see how I go. X plus 5 all squared minus 9. Now, we tackled these on Monday, so you don't have to do this, but let A equal X plus 5. And so this would be A squared minus 3 squared, or A squared minus 9. So it's A minus 3, A plus 3. And then I replace A with the X plus 5. X plus 5 minus 3, X plus 5 plus 3. And then that's equal to X plus 2, X plus 8. I hope you can appreciate now, particularly after Monday's lesson, that that is a much more efficient way of working than expanding X plus 5 squared, collecting like terms, and then factorising. It's a much more efficient process. This one here, 5x squared plus 12x plus 4, is there a highest common factor? No. Is it a perfect square? No. It's definitely not dots. It's definitely not monic, so it's a non-monic, and so I'll do it. Plus 20 plus 12. Circle that. Two numbers that will multiply together to give me 20, that will add together to give me 12, 10 and 2. So I put 10 down and I put 2 down. The plus here goes on the biggest number, so it's plus 10, and then I need to add another 2 to get it to 12. So it's plus 10 plus 2, 5x on top here, 5x on top here, and then I would cancel down. And the only place I can cancel down is here, 5 and 10. I'm left with, nothing there, or 1 there and 2 there. And so I finish off with equals x plus 2, 5x plus 2. Done. Okay? Diamond method's really quick once you've practiced it. So you just got to practice, practice, practice. Minus 2m squared plus 7m minus 6. Honestly, for me, I would probably take a minus out first and be left with 2m squared minus 7m plus 6. And then I would factorise 2m squared minus 7m plus 6. With 3 minutes to go, oh, I can do that. Why is that one there, that 9 minus m squared? It was a really easy problem to finish on, wasn't it? So let's focus on this one. I'll just quickly do this one. 3 minus m, 3 plus m. This one here, now I'm just going to factorise the inside. So I've got 2 times 6 is 12m, positive 12m, and I've got minus 7m to aim for in the middle. Circle this. Sorry about the m's, they shouldn't be there. I'm just rushing, that's why. Okay, so two numbers that will multiply together to give me 12, that add together to give me 7, 4 and 3. Put the 2m on top of both. The minus goes on the biggest one, so the minus goes there, and I need to get to -7, so that's -3 there as well. Cancel down. People shouldn't be packing up unless they've asked permission to. So the final answer here is minus m minus 2 and 2m minus 3. That's the final answer. There are combinations here. So, for example, m plus 2 times 2m minus 2. 2 minus m times 2m minus 3 would also work. There's a few combos there. But that's basically how I would do it. It is now 11:54. I shall pause this, stop this video.